Welcome to Physics Can Be Fun with me, Stephen Thomas. Today we're talking about substitution reactions which occur in the matric, grade 12 physics or chemistry paper 2, roundabout question 4, a question on flow diagrams. There we go, now we know where we are. So have a look what we are going to be doing here. In my previous video we talked about addition and elimination reactions which involved double bonded organic compounds. Now notice there are no double bonds anywhere here in our substitution reactions. What we're going to do is ask you to compare that molecule with that molecule. What is the difference? Can you see a difference? Well, the only difference is this. There's a chlorine, there's a hydroxyl group. OH, this is an alcohol, and that is a haloalkane. Let's practice how we name them. 1, 2, 3 carbons, methane, ethane, propane. It's got a chlorine on carbon number 2, 2-chloropropane. What is this? 1, 2, 3 carbon alcohol with the alcohol group on carbon number 2. So it's going to be propan-2-ol. So this is going from 2-chloropropane to propan-2-ol. And what are we doing? We're actually going to substitute that chlorine for that hydroxyl group. So it's going to take some sort of setup to get the chlorine to leave and go, and we have to provide a hydroxyl group in the form of potassium hydroxide, aqueous solution. This would be dissolved in alcohol with potassium hydroxide, mix the two together, heat it, and we find the chlorine comes off, combines with the potassium, that leaves this hydroxyl group with a spare space here to come in and react there, and so we form a alcohol. Just have a look at that. This alcohol is attached to a carbon that's got 2 other carbons with it. So we call that a secondary alcohol. If this OH was on the end attached to only 1 carbon, it would be a primary alcohol. So this is now a secondary alcohol because this hydroxyl group carbon is attached to 2 other carbons. So there we see there has been a substitution of chlorine for OH. Let's have a look at the second reaction. Notice we've got a primary alcohol, it's on the end carbon. What is this? 2 carbons with a hydroxyl group. It's an alcohol, so it must be methane, ethanol, or ethane-1-ol. There, combines with hydrogen bromide. You can also use sodium bromide solid. You need sulfuric acid, which will convert the sodium bromide to hydrogen bromide, and then it will swap out. Now let's have a look. We're swapping this for that. That's the only difference between the two. So we're going from ethanol to 1-bromo-ethane, which is a haloalkane. So we're using this as a catalyst, and we're going to introduce HBr. What happens is the OH comes off, marries the H, forms water, right? So H and OH forms water. The bromine is then left to come in and form that. So we start with 2 molecules, we end with 2 molecules, no double bonds. We start with 2 molecules, we end with 2 molecules. It's just a substitution reaction. Let's have a look at this third case here. Here we've got an unusual looking alcohol. See, this carbon's attached to 1, 2, 3. Primary, secondary, tertiary alcohol when this carbon is attached to 3 others. Tertiary alcohol plus HCl goes to form, now what's happened? That has been swapped with that. So we've got to take the OH off. The OH marries H, again forms water, and the chlorine is now left to muscle in and add there. So how would we name this, just as a matter of interest? Well, look for the longest chain. 1, 2, 3 carbons, so it's methane, ethane, propane. It's got two branches. We name them alphabetically. 2-chloro-2-methyl propane. And so that's the substance that's formed with water released. If water is released, dehydration kind of reaction. In this case too, we could have added water to this and it would slowly replace the chlorine with OH. And so we could also call that a hydrolysis reaction. Hydrolysis, hydro, water, lysis, splitting, adding. So a reaction that is going to involve water. Now, if you're looking for a way of remembering this kind of stuff, I always look at it like as follows. In chemistry, you have potassium. Now, potassium's a metal. Now, think of metal, M-E, as men. Metal, men. Metal equals men. Just a way of remembering it. So all the metals, potassium is a metal. Then we think of our non-metals as women, if you like. So this man, potassium, is dating OH. OH, potassium forms a positive ion. All the metals form positive ions and are found on the left of the periodic table. All the non-metals form negative ions and are found on the right. So we can consider OH as a kind of a woman. If this is just a mnemonic, don't call me sexist, it's a way that I think of chemistry. K is married to OH, or is dating, nothing marries in the chemistry. Think of chlorine, again on the right of the periodic table, non-metal, as a lady dating this propane. They are in a marriage of convenience. But chlorine is not that happy with propane, and potassium's not that happy with OH, because potassium's pretty hot and chlorine's pretty hot. So these two pretty hot things want to get together with each other and leave these unhot together. OH not very hot, propane not very hot. They're about 3 on the hot scale, if you like. Potassium and chlorine are both about 8 on the hot scale, if you're thinking of men and women. And so the two hotties get off together, and the two not so hotties also end up with each other. Look at it like this. There's H and Br. H is an honorary metal. It's found on the left of the periodic table with all the other metals like sodium, potassium, and lithium. So it's in group 1 with all the other metals. It forms a positive ion, like all metals. And there's bromine, a non-metal. So hydrogen, sort of the most girly, ugly man, is going and dating a pretty hot non-metal, or girl. Think of it like that. And they come together, and here is ethane in a relationship with OH, which we can think of as a girl. So now we're going to find that H goes off with OH, two not so hotties, and then bromine is left to date ethane. That's just a way of thinking about it. So it's considered two people dating. The two couples break up and swap, and boom, they go out with each other. Okay, here's another case. There's H metal with non-metal. There's OH non-metal. So we can swap the non-metals, and then there's hydrogen is going to go out with OH and form, there's the couple, water. So it's a new couple formed and a new couple formed. And so you can just think of it in those terms if you want a way of remembering what substitution reactions. It's like couples and couples, they break up, both couples break up and reorganize as new couples. And there we go, that is a substitution reaction.